Good morning students and welcome back to chemistry class. Last class we have learned about the different types of concentration of ore and we have just started with how to convert the concentrated ore into oxide with the help of two processes according to the type of ores, that is calcination and roasting. Today we are going to the third step, that is how we are going to reduce the metallic oxide. Now there are different ways to reduce the metallic oxide. So the first method which we are going to study is chemical reduction. Now chemical reduction, this is a kind of method in which the metallic oxides are reduced to metal in the presence of carbon at elevated temperatures, or at high temperatures. Now especially those elements which are moderately electropositive, like metals like zinc, then we can say there are some other metals like your lead, then iron, then tin. This kind of metals, they can be reduced to metal in the presence of coke or carbon at a high temperature. Now here you see there are some examples I have written. Metal oxide plus coke gives you the metal plus release of carbon monoxide. So here zinc oxide, lead oxide, SnO2, Fe2O3, these are all taking place. That means the chemical reduction of these metals are taking place at high temperature. Now at low temperature we will see that we cannot use carbon as the reducing agent. So at low temperature we are going to use carbon monoxide as the reducing agent. So here you see the oxides gain Fe2O3 with carbon monoxide at low temperature can be reduced to iron plus carbon dioxide, and zinc oxide can be reduced to zinc with the release of carbon dioxide. Similarly lead oxide and SnO2. So at low temperature in the presence of carbon monoxide, the metallic oxides can be reduced to metal. Now sometimes what happens during the process of smelting process, we also have the impurities. The metallic oxides have impurities with them. So what is done? Flux is added. The acidic flux or the basic flux are added so that it comes out, the impurities are separated out in the form of slag. So what are these flux actually? So flux are substances which are used to convert non-fusible impurities into fusible ones. So three types of flux are used, that is acidic flux, basic flux and the neutral flux. So acidic flux, you see, substances which are used to remove the basic impurities, metallic oxide. So you see calcium oxide, that is the basic impurity which may be present. So the acidic flux which we can use is silicon dioxide, and slag will be separated in the form of calcium silicate, that is CaSiO3. Now acidic flux are non-metallic oxides. Those acidic flux which can be used to remove the impurities in the form of slag, those are actually, in case if it is acidic in nature, they are non-metallic oxide like silicon dioxide or phosphorus pentaoxide, P2O5, like that. Now next one you see basic flux, substances which are used to remove the acidic impurities, that is non-metallic oxide. Now suppose the acidic impurity which is present is silicon dioxide and we are going to use the basic flux. So the basic flux plus acidic impurities will give you CaSiO3. So it depends upon the nature of the impurity actually, what kind of flux you are going to use, whether it is acidic flux or whether it is basic flux. Then next you see neutral flux. So these are substances which are used in the electrolytic reduction. You will see that it will be used in the electrolytic reduction of alumina, where we are going to reduce the fusion temperature and we are going to increase the conductivity of the solution. So here you will see cryolite, and along with that you see fluorspar. See the formula, Na3Al(F6), that is cryolite is used along with fluorspar. Also sometimes calcium chloride is used as a neutral flux. So this is about your chemical method. Now next one you will see another method, that is called, in chemical reduction method there is a process, aluminothermite process, or you can say thermite welding process. This is something which you have already learned in class 10. Now in this process what happens, the metallic oxide will be reduced which require high temperature, and at high temperature carbon reacts with metal to form metal carbide. So in this process those metallic oxide will be reduced which require high temperature, and at high temperature carbon react with metal to form metallic carbide. Now in this process we use aluminum as a reducing agent. Why do we use? So here you see aluminum has greater affinity towards oxygen because it forms what? Metallic oxide, that is aluminum oxide. Now this reaction is highly exothermic in nature, and once it starts it continues till all the metal oxide is reduced to metal. You see the reaction given here. Cr2O3 plus Al will give you aluminum oxide plus chromium, that is chromium oxide is reduced to metal. Then you see Fe2O3 with aluminum will get aluminum oxide plus iron. So here you see aluminum being a more reactive metal compared to iron and chromium is used as the reducing agent. Now so this is a process which is also known as the aluminothermite process, or it is also known as the thermite welding process. So this reaction, generally the reaction B, Fe2O3 plus Al gives rise to Al2O3, is used in the welding of railway tracks. Now next is called self-reduction. Okay. Now compounds of certain metals are reduced to metal without using any additional reducing agents. So as the name suggests, self-reduction means, so here you need not use any kind of reducing agents. Here the metal oxides can be reduced to metal without addition of any reducing agents. So let us see some examples here. Just see this one. Okay. The sulfide ores are partially roasted to some oxide like lead sulfide or you can say zinc sulfide. This oxide is now reduced to metal by the remaining sulfide ore. So here you see lead sulfide plus oxygen will give you lead oxide plus sulfur dioxide. Now if the remaining lead sulfide which is left over, that is allowed to react again further with lead oxide, which will give you reduction in the lead and along with the sulfur dioxide. So this is known as self-reduction. So you can say that sulfide ores, they are first partially roasted to give you some oxide. This oxide is now reduced to metal by the remaining sulfide ore at elevated temperature in the absence of air. You will see that the second step is in the absence of air. So this process is known as self-reduction. Now this self-reduction process, it can be used in copper. When we will do the extraction of copper, the steps which are done in the extraction of copper, we will find this again. Okay. So here you see the copper sulfide plus ferrous sulfide in presence of flux SiO2. Here SiO2 is acidic flux. So we get blister copper plus the slag. So here we will see that the ferrous sulfide along with oxygen, first it will give you ferrous oxide plus sulfur dioxide. Then that ferrous oxide will further react with SiO2 to give you FeSiO3, which is slag. Okay. Now here again the last step you see copper sulfide, that is copper in the form of sulfide plus oxygen will give you Cu2O plus sulfur dioxide. Now this Cu2O will again react with the remaining copper sulfide, which will give you copper plus sulfur dioxide. So this is taking place at a very high temperature. So this is an example of what? Self-reduction. So we have learned the chemical reduction, we have learned the self-reduction. Now next reduction process we will see, this is metal displacement method. So in this method the compound is allowed to react with a more electropositive and more reactive metal which displaces the metal from the solution. Okay, this is just like the single displacement reaction. So here what we will do, the compound, we will treat the compound with a very reactive metal which is compared to be more reactive than copper. Suppose here we have taken zinc, so we will get zinc sulfate plus copper. Okay, so here you will see that metal displacement reaction is also a process with the help of which we can reduce a metallic oxide to metal. Now the last one you see, electrolytic reduction. So this process is mainly used for the extraction of those metals which are highly reactive or highly electropositive like aluminium. Okay, electrolysis is carried out even with sodium. Electrolysis is carried out on a large cell and a small amount of another suitable electrolyte is added. okay, what they will do, which will lower the melting point of the main electrolyte, which will enhance its conductivity and which will reduce corrosion troubles. For example, you see, manufacture of metallic sodium through a process known as Downs process. So here what it is given, you see, metallic sodium, molten sodium chloride containing a little amount of another electrolyte, that is calcium chloride, is electrolyzed between the graphite rods and the iron cathode. So the reaction will take place at the respective cathode and anode. So on fusion, what happens? Sodium chloride, in the molten state, it will give you Na plus and Cl minus ions. The ions becomes mobile. And on electrolysis, what happens? At cathode, the sodium plus ion will receive the electron and it will give sodium metal, that is metallic sodium. And at anode, what happens? The chlorine minus will receive the 2Cl minus will give the chlorine gas with the release of 2 electrons. Okay, so this is actually the two reactions which is taking place at the cathode and anode in case of electrolytic refining of sodium metal in the Downs process. So students, these are the 4 methods which we have learned regarding the reduction of metal oxide to metal. Okay, please write down these 4 methods in your copy along with the examples which are given here. And if you get any question, any short questions, you get generally short questions here, 2-mark questions or 3-mark questions from this chapter, so that you along with your MCQ also you get sometimes, or you may get the assertion reasoning type of questions, you should be able to answer the questions. Okay, so with this I end the topic here, and in the next class we'll start with another new topic related to the extraction of metals. So actually we have reached the 3rd stage, okay, and the 4th stage is refining of metals. So before we go to the 4th stage, we need to go through some thermodynamic principles and some electrochemical principles also, which is related to the extraction of metals or in metallurgy. So thank you, my dear students, for listening, and have a great day ahead.